All right, so for this next part, we're going to look at finding the probabilities of rolling a six-sided die. And we're going to write the results as both a fraction and also as a decimal. And so the first one we have probability of rolling a 4. And so remember, our sample space for rolling the dice is all the 6 sides. So there's either 1, 2, 3, 4, 5, or 6. And so rolling a 4, that happens one time out of those 6. And again, we could write the decimal for it too, which is going to be approximately 0.167. Which actually, I mean, let's write that. Let's write it a little bit better because I'm going to write it as a percent, but let's write it 0.167. All right, next we have not rolling a 6. So really we know that rolling a 6 is 1 out of 6. So the complement is going to have to be the rest. So if we think about what would make the rest, what would make a whole? That'd be 6 out of 6, which is 1. So this is the complement of rolling a 6. You could also just count 1, 2, 3, 4, 5. There's 5 other ways that you can be not 6 out of 6 possibilities. And so we have 5 divided by that 6 is going to be equal to 0.83333. So we'll round that to 0.83. For the next one, P, it says rolling an even number. So what we're talking about here is going to be the numbers 2, 4, or 6. So there are 3 possibilities out of 6, which is equal to 0.5. Next we have rolling a number less than or equal to 4. So the numbers that are less than or equal to 4, that would be rolling a 1, 2, 3, or 4. So there are 4 different ways that that can happen out of 6, which if we write our decimal for that, that is going to be 0.67. All right, now rolling a number greater than 4. So again, that's basically the complement of what we just had because we don't want to include 4 this time. We just want the 5 and the 6, which is going to be equal to 2 out of 6, which is about 0.333333333. All right, now rolling a number between 1 and 6. So between, that would be not including, so either a 2, a 3, a 4, or a 5, which is going to be equal to 4 out of 6, which is 0.67 about. Now rolling a 7. 7's not even in our sample space, so we would say that that's an impossible event, so the probability of that happening is 0. For the probability for a multiple of 3, so multiples of 3, that'd be 3, like 3, 6, 9, but 9's not on the dice, we stop at the 6, so that will happen 2 out of 6 times, which is about 0.33. All right, for exercise 4, we're going to be flipping a coin, then rolling a die. So we're going to draw a tree diagram, which we've done before, but it's okay to kind of remind us about what that sample space looks like. So you could roll ahead, or flip ahead, and then roll a 1, 2, 3, 4, 5, or 6. And same thing with the tail. You can flip a tail and then get a 1, 2, 3, 4, 5, or 6. So then our sample space, we go over here, we'll write it in our set notation. It's going to be a heads with a 1, a heads with a 2, heads with a 3, heads with a 4, heads with a 5, heads with a 6, and then tails with each of those. Tails with a 1, tail 2, tail 3, tail 4, tail 5, tail 6, and I'm going to end with that curly brace. So remember, that's our set notation, that everything is separated, all the elements are separated by commas in there. And so the cardinality of this set that we've just written for our sample space is equal to 12. There are 12 elements in it. So now we want to see, well, what's the probability of getting a head and a 4? So that happens one time. So that will be equal to 1 out of 12. I didn't say to write it as decimals this time, so I'm just going to write the fractions out. It's a little faster here. Probability of getting a tail, that would be 6 out of 12, we could reduce the fractions. That would be 1/2. It's the same thing. Probability of rolling a 6. Well, that's going to happen 2 times, either with the head or with the tail. So 2 out of 12, and again, you could reduce that to 1/6. Now, the probability of getting a head or a 4. So a head, that will happen 1, 2, 3, 4, 5, 6 different ways. Or a 4, we're going to have a total of 7. So that will be 7/12. Now, the probability of a tail and even. So a tail and even. So we need to look at just the tail possibilities. And we have 3 there. So it's going to be 3 out of 12, or we can reduce that to 1/4. And then the last one here, the probability of getting a head and 7. I just took out all these. Let me fix the top here. Okay, there's my sample space. Erase part of it. So getting a head and a 7, well, it's impossible to get the 7, so we're back to our 0 for our probability. So there's a couple of different rules that we have seen and different ways to write out these probabilities without actually having our whole sample space there. So if we have 2 events, A and B, and you can think about the events that we had, which were flipping a coin and rolling a dice. Those are 2 independent events. The probability that both A and B occur is found by multiplying the probability of A times the probability of B. So when we look at the probability of A or B happening, or both, that's going to be the probability of A plus the probability of B minus the probability of both of them happening. It's like minusing that intersection. And we did something similar to that when we were looking at the Venn diagrams. When we would want to find the union, that was kind of like our OR, right, of all the sets. We would not want to double count that intersection, so we would take it out. So the same thing's kind of happening here with probabilities. So after reading those important definitions, let's find the probabilities using those formulas. So we have probability of H and 4. So using that formula, we want to find the probability of getting a head, and then we're going to multiply that by the probability of rolling a 4. So the probability of a head is going to be 1 out of 2, and the probability of rolling a 4 is 1 out of 6, which gets us 1/12. The probability of rolling a 6, that's just singular event, we'll get 1 out of 6. Probability of tails and even, so let's look at the probability of tail times the probability of an even number being rolled. So the probability of a tail is 1 out of 2 times probability of even. Remember that was getting a 2, a 4, or a 6, so we'll have 3 out of 6, which becomes 3/12. Again, we can reduce that to 1/4. Probability of getting a tail, that's just one event there, that's half. Now we have probability of a head or a 4. So we're going to take the probability of our head plus the probability of rolling a 4, but we want to minus the probability of that intersection, which is a H and a 4, because of that, again, that double counting. So the probability of getting a head is 1/2. The probability of rolling a 4 is 1 out of 6. And then we're going to subtract off the probability of getting a head and a 4, which we had in that first one there. That would be 1/12. So working with fractions, you can enter this all in a calculator, but I just see that the common denominator would be having a 12, so they were all the same sizes here. So this will multiply by 6, this multiplied by 2, so we're talking about 6/12 plus 2/12 minus 1/12. That's going to be a total of 7/12. And the last one, the probability of H and 7. So following our formula, what's the probability of getting a head times the probability of rolling a 7? Probability of head is 1/2 times the probability of 7 is 0. That's going to get us 0. And so the last thing it said is it wanted to verify if we were getting the same results by kind of looking back up, looking at using those formulas versus the sample space. So they should all match up. So the probability of getting H and 4, we said was 1/12. That matches. Probability of 6, 1/6. Probability of getting tails and even was 1/4. The probability of T, we already have that. Probability of heads or 4 was 7/12, which matches with that. And probability of 0 and 0 matches. So we got it all. We verified that.